Histograms are bar charts where the y-axis contains the frequency of a variable. Let's say you have blood sugar level of different patients in a hospital, and you want to know how many patients are normal, pre-diabetic, and diabetic. In this case, having a chart like this could be useful, where these different bars represent different blood sugar ranges, and the y-axis contains the number of patients who are within that range. For example, you have 4 patients who are above 125 sugar level, and hence they are diabetic. We are going to plot this histogram in Matplotlib today. As usual, I have launched my Jupyter notebook by running this command on my command prompt and imported Matplotlib pyplot as PLT. I have put all the sugar numbers for different patients in this list. I don't need the names of these patients because when you're working with a histogram, you need only single dimension array, and the y-axis will contain the frequency of those different numbers. To plot histogram, you can call plt.hist, pass in the array or the list, and simply execute that, and that will do it for you. Now, by default, it will plot 10 bins for you. So in histogram, there is a concept called bin or a bucket, which is nothing but really a range. In our case, we want 3 different ranges, right? Like 80 to 100, 100 to 125, and above 125. But by default here, histogram plotted 10 bins. So you can see that these are the bins, and these are the y-axis numbers. Okay, so let's play with this bins parameter a little bit. So you can do a couple of different things with this bins parameter. So by default it is 10. You can reduce it to whatever number you like. So let's say I want to reduce it to 3. Okay, now it looks a little better because I have 3 bars, but these bars are joined. Okay, so I can make them look little better by supplying R width parameter. R width is basically a relative width of a bar compared to a bin size. So maximum value is 1, so I want it to be 0.95, which is like 95%. So now this bar looks little better. This is like 0.95 of the entire range. Now by default, it selected bin sizes on its own by doing some equal distribution. So you can see the ranges that we are using is 77 to 101, and then 125, and so on. You can customize this range and change your bin parameter to specify the range explicitly. So remember, our blood sugar levels are 80 to 100 is normal, 100 to 125 is pre-diabetic, and anything more than 125 is diabetic. So I'm just going to put some max number. I know I don't have any patient with like ridiculously high sugar, which is like more than 200, so I'll stick with that. Okay, so now this is how it looks. I can probably reduce it to 150 to make it look a little better. Okay, if you check the API for hist function, there are different parameters you can pass. You can pass parameters like color. So let's change the color of this chart, and here you can either say green or you can use abbreviation, and both of that will work. You can also have hist type set to be step. So in that case, instead of the hard rigid bar, it will be like as if you are having the steps. Okay, so you can try that. Okay, so now let's say you have 2 different samples. So right now you are having blood sugar levels of men, and let's say for the woman you have those samples in a different data set. So I'm just going to copy some static data once again, and say I want to now plot two type of histograms, okay, side by side. You can do that easily. Just change the first argument and make it array. Okay, so now I have a list, and in the list you can pass both of these samples. Also, for convenience, I'm going to use two different colors. So let's say I will use green for the first sample, orange for the second sample. And you can see that now I have side by side histograms. The thing that this is missing is I don't have any labels, so I don't know what chart is what. So I can add those labels easily by supplying label parameter. So the first chart is men, and the second chart is for women. Also, I will enable legend. Okay, you can also set your X label, and X label is sugar range. Y label is your frequency, or like total number of patients, and the title is your blood sugar analysis probably. So now my chart looks much better. I have two side-by-side histograms, one for man, one for woman, and this is showing the blood sugar levels along with the frequency. When you have this kind of chart, it helps you analyze and compare the different ranges, right? Here, for example, I can say that number of patients who are normal are more than the number of patients who are either pre-diabetic or diabetic. So you can do like comparative analysis with different data sets and different groupings within the data set. So histogram this way is a very powerful data visualization tool that you can use in solving any given problem. One last property I wanted to show you is orientation. Orientation, where you can plot histograms in a horizontal fashion. So sometimes people like histograms to be in this way. Okay, that's all I had for this tutorial. I have provided a link of this Jupyter notebook in the video description below. As usual, I'm going to say that you don't learn coding just by watching this tutorial. You have to download this notebook, play with it, and try different data sets and different histogram properties, and that would be the only way to learn it. Okay, thank you very much for watching, and goodbye.